Hi, hello there. Today we are discussing about multi-phase energy metering, one of our product development videos. Here we are discussing two types uh, MCUs. One is pre-programmed, that is you no need to do any coding. Anything you can readily used. It can be used readily. That many kind of many MCUs are available in this energy metering. That is all the items are pre-programmed. That's ADC, the conversion, the calculation, everything is pre-programmed. So you can select different MCUs in there. That's a different thing you can search in. Another thing is we can select any MCU and you can set ADC. That's more you have more freedom and you have the choices to do. That's a you program your own. So two kind of thing we are discussing here. So this is the block diagram. It's a current, voltage, and frequency. This samples we are taking, and this CPU, it's processing everything. It has a power data management system, ADC, CPU, memory, everything, and in support of clock, storage, the button, the menu selection, that kind of thing, display, the communication. If you need the RS485, this is a general block diagram. So. Like this in nowadays a modern kind of multi-phase energy meter works like this. So this in this tutorial we're discussing about ADE 7878. It is a analog devices microcontroller. It's embedded. It's a all the calculation, everything is embedded in it, so you can directly connect the ADC or the current transformer, everything into it, and you can get the reading. The another kind, it's here that we can go to there. Actually, I think it's here it is. This is any MCU we can select here. This is AD7755. It is an analog to digital converter that we can select to get the right value to the MCU for the calculation. So here we can program the custom. We can do the programming as a custom programming, and here the what do you call it? Current transformers 1, 2, and 3. So three current transformers getting the three phases A, B, C. Phase A, phase 1, 2, 3. That's A, B, C, and N is neutral. So you can get the three phase 1 neutral. That is three phase 4 wire system here. So this has the power supply for this entire system. This is the display. This is the indicators, the EEPROM, and everything is in here. So this is a custom MCU that we need to select any MCU and make the programming and use this AD7755 ADC converters to do the work. Initial setup here. Actually, um, this is a phase 1 setup. It's a CT. It's a current transformer. You can see the short forms here. You can check and in detail. This is a current transformer. This is a core. This is a winding. So this these pins. There's a V1, the V phase 1, I phase 1, and neutral. It goes to the ADC pins of the metering hardware. So here, if you are using multi-phase, if you are using three phase, you have to make this one these three numbers actually. This is for one phase, so you need to make three CT for each phases. So you need four phase. You have to make four CT, and these arrangement, four times. So you have to using two phase, then you have to go to each phase. So this is phase 1 cable. So you need to the cable should go inside the core of the CT. So then it goes to the load, phase 1 load. the phase 1, this is the phase 1 voltage. This is a current transformer winding, so the winding, and it should also go to the ADC pins of the metering hardware, and the one neutral. So you can make this setup. This is a basic setup. We can the CT ratio. There's a CT ratio for current transformer ratio that is called for 500 amps. You have to reduce this proportionally to it's make it readable to the ADC pins of the metering hardware, whichever you're using. So that we are discussing next step. So this is the initial setup. It's a current transformer, and the voltage from the current transformer itself, it will take the frequency. So from this winding, it will take the frequency also, and it will calculate the whichever the IC, the power IC, power metering IC taking as per your design. You can check that. Here we are discussing the analog devices IC. You can check. One moment. Okay, yeah, here. So analog devices ADE7858. This series is 785, 7878, 7858, 7868. This is a pre-programmed one. You don't have to code anything into it. So here it is. This is a analog devices page. ADE7858, 7878. So there's a series. I mean, 2-3 chips, 2-3 MCUs into a single. They're given like this. This is the datasheet. AD7854, 7858, 7868, and 7878. So polyphase multifunction energy metering IC with harmonic and fundamental information. So okay, so and this is the analog website. You can see the evaluation kits, documentation, product recommendation, reference materials, design resources, support discussions, sample and buy. Everything is here. About this AD7858, you can. This is a multifunction energy metering IC. This is a product categories, AD converters, energy metering ICs. So here's a high accurate support, EN standard, the European norms, international standard EC, everything it's mentioned here. So compatible with three phase, three phase, 3-wire, 3-phase, 4-wire, and three phase services. Supplies total, fundamental and harmonic, active, reactive, apparent energy. All the calculations is embedded into this chip, this ADE7878. You don't have to code anything. I repeat. This evaluation kit, so you can check it in the website. So here the analog devices, polyphase multifunction energy metering IC with harmonic and fundamental information datasheet. So in here there's 75, page number 75. 75. So yes, it is the quick setup as energy meter. It's a quickly setup AD7858. These are the pins. This is a normal setup. Here you can check the voltages. See the voltage input I. This is current inputs I, and the V. This is a voltage input. You need to thoroughly check the data sheet for the correct connection to the what do you call it, the current transformer and the voltage. So you need to thoroughly check it, the what do you call it, data sheet. It's a must for any design, so I don't have to go in detail with that. So data sheet, it's a must thing. So you can check the data sheet for the detailed documentation and design setup. Here's a sample top layer of a PCB is given here. There's an evaluation board, so you can check that if you really going to design it. So there's a lot in the, it's 100 pages data sheet, so I don't have to go through all into it. So this is a nice design. I think so, because it's a simple and direct, so you can check it. So once again, about the about the CD, the current analog to digital converter pins, and this setup is important. It should be accurate. The CT design is it should be accurate, because if you are measuring 100 amps AC, so this you have to make that 100 amps to 100 is to 1 or 100 is to 5, or there's a standard reducing proportions, so you can refer current transformer design in detail, and that's another big topic, so you have to check that. This is actually the current transformer here, and the voltage, reference voltage you're taking here for one phase, this one. So second phase, the same design should repeat, and any phase, any n number of phases, n number of transformers, n number of these pins. Only one neutral is one, so one neutral, three phase. If it's in the three phase, four wire, and if it's in the three phase, three wire, it's three phases. There's a connection, you can check in the CT and voltage current design. So that's another topic you can easily check online, or you have an electrical design book or something, you can get it and check it. And one more time, this ADE7878. I think right now that's all. Hope it's informative.